All right, so chapter 12 deals with what we call the exception handling. Okay, exceptions here. I think you might have already, I'm not sure if you used this before in the code or the example in the book. I can't remember, but you have encountered this before. Okay, every time when you do an input read and read, let's just say you're expecting a number, but you punch in the character and your program crashes, right? That's an exception. Every time when you do a math equation, like, we know since grade school that you can't divide it by 0. That's illegal. We were taught that way, and that is an exception, right? It's an error. That division by 0, that kind of varies depending on the IDE you use. Like in Eclipse, if you do a division by 0, it will not crash your system. Your program will still run. You will get a weird result, but it will still go on. It won't crash your program. However, if you run in a different IDE, like if you use NetBeans, NetBeans will say it's a division by 0, it's not allowed, it will crash your program. I mean, if you don't catch it, right? You don't catch the error. But in Eclipse, you see that you have an answer called infinity. We'll talk about that later on. Okay, so you have these things called exceptions, and exception is a type of error. Okay, so errors in Java is categorized into two major categories, and here you see the error and the exception. Okay, when we say error in Java, in that category, we mean things like we can't control. Things like when you run your program and when it's running and suddenly it crashes because it uses all the resources and it crashes, it runs out of memory. Like things like that we can't control in the program, right? So these are called errors, and they're fatal errors, right? So those we can't fix them. Okay, we try to avoid. So that's when you code, you want to make sure you close all your scanner input, close all your database connections when you're done with them, so they don't leak memories, and because they will accumulate in your program, and the more they accumulate, they will consume a lot of resources, and then it crashes because out of memory, right? So you prevent that from happening because you can't control the other part. Now the exceptions is a type of errors that we can control as programmers. Okay, a really good code or a really professional code, you see that you will capture all these type of errors in the program. If you don't catch them, they will crash your program. Your program will stop running. But if you do catch them, then the program will still run. Okay, will just continue running, but you get a incorrect result. At least they're not fatal, right? So that is the good thing. You can capture those and then fix them. And another term for that is to handle those errors. Okay, that's why you have this thing called handling, exception handling. How do you handle those type of errors? Okay. So in the Java program, this is also in the book. You'll see that I'll show you also in IDE. You have two major categories under. So this diagram kind of shows you that under the object class, this is the like the mothership, right? Object is the ultimate object class that every other class is derived from. Even when you write your own classes, its parent or its grandparent is the object class. Even though you don't specify that explicitly, it's still the object class. So all other classes in Java are descendant of the object class. Otherwise, there's no object. There's no classes in Java. So that's the highest class. Under that, you have a class called throwable. Okay, so this throwable class here is the parent of all the error classes. We have the exception. If you follow this line down here to the next page, you see that the other class is called the error, right? Java.lang.error. And then on the same level, if I scroll up again, you see that Java.lang.exception. So we have those two categories. And then the error, again, those are things we can't control. But on the exception, there's a lot of them. There's like probably about a dozen of them. Here only shows about maybe half of those type of errors. But these are quite common. And I'll show you some of the examples how they can occur in your code. Okay, and how do you fix them? How do you catch or handle those errors? Okay. So again, here is the hierarchy of the classes. Under the throwable, you have the errors on the left side. we can't do much about those, but on the exceptions, you can control those. We have two subtypes, the runtime and the other exceptions. Things like, your syntax, right? Syntactic errors, and those are easy to fix. But the runtime exceptions, those like your logic errors, sometimes those are a cause of your syntax errors. Maybe your syntax was not correctly coded, and maybe if you don't use your IDE, then your IDE doesn't, that program doesn't tell you what the errors are until you execute your code, right? But using an IDE like Eclipse or NetBeans, they will catch those for you and you fix them right away. So you have the runtime errors. These are mostly, again, the logic errors. Well, it says 3 types here, but basically it's still going to be under those 2 big types. Okay. The errors again here, these are what I talked about, things that we can't control. The 2 types of the exceptions are the checked and the unchecked errors. Okay, it just means that when do these errors occur? Okay, do they occur when the application is running? If it is, then these are the unchecked because we can't check them until we run the program. Then we have those errors. Then the checked exceptions are occur during compile time. Right? So when you run the application, if there's an error in the code, it compiles it, it catches the error, and then it throws an error. Like if you forgot to set or initialize your string variable, a local variable, you forgot to initialize it and you run it, it will crash. That's compile time, right? So that's the check exceptions. Anything that's run during runtime that causes error, those are the unchecked because you can't check them. Okay, so I have here a link to a list of all the exceptions. If you want to look at here, they have a pretty good list of all of them here. You have about 12 of them. Okay, these are the ones that are built into Java, and of course, plus your own. You can write your own custom exceptions as well. It depends on how you want to do it, right? Maybe you write a program that only allows, people under the age of 30 and between 25 and 30 can only, join a club or something like that, or can sign up for some type of program. Then you throw that exception right under your range exception or something like that. So you have your own custom exception as well. But these are all built into Java. And so it's pretty good read here. Well, of course, you can always go to the Java doc and find that in there too. Okay. The next thing is the stack trace. Okay, stack trace here you see all the time. You just probably haven't noticed it or didn't pay attention to what it is, or maybe the book didn't explain it yet. But a stack trace is basically a trace of every function or every class, every method you call in your code, and then from there all the way to the main program or main function that make that call of that causes the error. And again, I'll show you a few examples in there as well. We'll see it. So you can see the stack trace, and you can track where the error occurs in which class or which function called, and then so you can have some idea of how to debug your code. Okay, so very helpful. So something like this, you see it already, pretty sure. Now, when you handle errors, you have, of course, you don't have to use Java's method, right? You can always write your own. This is an example of it's just a really basic way of how to handle that. But if you think of a way to handle, like for example, division by 0, how would you handle that without using the built-in exceptions handling? How do you handle a division by 0? While loop? Yeah, okay. Right, yeah, while loop or right, so before you do a division, you will check the number first, right? You check the denominator, right? Make sure that it's not 0. So if it is 0, then you say, this number can't be 0. Please enter again, right? So you check the error that way. If you don't check it, then again you get the incorrect result. So that's just by doing your own method of error handling. Okay. or in Java, and not just Java, most languages have this built into them, especially object-oriented programming languages. You have this thing called try and catch. Okay, you have try, catch, and usually have a finally. Didn't show here, but it's a mechanism that allows you to test a particular piece of code that could potentially generate errors. Okay, you don't want to try every single case. Just those cases that you think that might cause an error. Okay, because you want to try and make sure that it's okay. If it's not okay, then catch the error, right? So things like if you want to read from the input, those type of code, you always want to try it, right? Try it, make sure that you read the correct data from the user, validate the data, make sure it's correct data. If it's not, then you catch the error. Okay, otherwise you have it's a leak or a bug in your code. Okay, you read data. Every time we read input, you always try to catch that. When you do some type of mathematical calculation that involves some numbers that you may not, that you can't guarantee that will be safe, okay, try that. Okay, make sure that it's legal. Or when you do a loop through an array, again, things like that, right? Make sure that the array is not empty, and then you index values, index numbers, are not larger than the size of the array. Things like that can cause errors. So anything like that, you will see it, that you put those in the try-catch block. Okay. So the try-catch, as you can see here, has a multiple catch statements. Okay. Some languages don't let you do this, especially like if you try, I think like JavaScript. I mean, it won't let you do multiple catch statements. It will be just one. Try, catch, finally. That's it. Okay, but in Java, it allows you to catch as many as you want. Okay, I mean, you can't catch the same type. It has to be a different type. But you can catch all those like 10, 11 error tests we just saw, plus your own custom errors. So that's because each of these catch blocks are very specific to a certain type of error. Okay, and then there's a built-in catch error that can catch all of them. It's called the exception. And I'll show you how to do that. But so let's look at the try-catch block in the code, and we'll just kind of go through some of those examples on the list I showed you a while ago, and see how we can handle errors.